Hidden away in a forgotten corner of industrial Europe, there existed a locomotive that nobody was supposed to know about. Its construction took place behind locked doors, under conditions of extreme secrecy that would have made a military weapons program look transparent by comparison. When it finally emerged into daylight, it would challenge everything the railway world believed about what steam power could accomplish. But its story isn't one of triumph. It's a story about ambition that exceeded not just engineering capability but geopolitical reality itself. This is the tale of the most classified locomotive ever built, a machine so controversial that when it finally came time to decide its fate, the decision-makers had to choose between history and politics won. The year was 1938 and Europe was holding its breath. The machinery of war was beginning to hum in distant factories. Nations were building production capacity, stockpiling resources, preparing for a conflict that everyone could sense coming but nobody wanted to admit was inevitable. In the midst of this atmosphere of anxiety and preparation, one European railway company made a decision that would consume resources and attract talent for the next 3 years. They decided to build the perfect locomotive, not the most powerful, not the largest, but the most perfect in every conceivable way. The country was Switzerland and the railway was the St. Gotthard Railway Company. Their mandate was to move heavy freight and passengers across the most demanding Alpine terrain in Europe. The St. Gotthard Pass represented one of the most severe tests any locomotive could face. The grades were steep, the curves were unforgiving, the weather was savage. For decades, the railway had relied on conventional designs, pushing them to their limits, extracting every last ounce of performance through careful maintenance and skilled operation. But by the late 1930s, the railway's engineers were convinced that conventional approaches had reached their ceiling. They wanted something more, something that would make every competitor in Europe look outdated by comparison. The chief engineer was a man named Dr. Heinrich Vorster, a locomotive designer whose reputation rested on a simple principle. Every problem had an elegant solution if you were willing to pursue it far enough. Vorster had spent a decade studying the failures and limitations of existing Alpine locomotives. He had ridden footplates, interviewed drivers, examined worn components, traced metallurgical failures back to their roots. What he concluded was radical. The problem with existing designs wasn't that they weren't powerful enough. The problem was that they weren't intelligent enough. Vorster's concept was to build a locomotive that would, in effect, think. Not literally think in any conscious sense, but rather possess mechanical systems that would automatically adjust to changing conditions, that would distribute loads intelligently across all available mechanical systems, that would optimize fuel consumption in response to gradient and track condition. It was, in essence, the first self-regulating locomotive. The technology that would make this possible didn't exist yet. Vorster would have to invent it. The decision to pursue this project in secret came from the railway's board of directors, who understood that what they were attempting was politically sensitive. Switzerland had maintained a position of careful neutrality, but the country was surrounded by increasingly aggressive militaristic powers. A locomotive that represented a quantum leap in Alpine transportation capability could be seen as strategic military advantage. More dangerously, if the project failed, if it consumed massive resources and produced nothing, the political embarrassment could be severe. Better to work in shadow until success was assured. The facility chosen for the work was an old locomotive works in Winterthur, a place with skilled craftsmen and access to resources, but also relative isolation. The workforce was carefully selected, not just for technical skill, but for their willingness to work under conditions of absolute secrecy. They were told they were building something important for the nation, something that would require their devotion and discretion. Most understood that they were involved in something classified, though the true scope of what they were attempting remained compartmentalized. Workers in one section didn't know what was happening in another. Vorster's design specifications were extraordinary in their detail and their ambition. The boiler would be the largest ever fitted to an Alpine locomotive, capable of producing steam pressures of 350 pounds per square inch. The heating surface would be optimized through a system of preheating that used waste heat from the exhaust to warm incoming feed water before it entered the main boiler. The firebox would incorporate a mechanical stoking system, the first time such a system had been attempted on a locomotive of this type. The power delivery system would use a compound design with 4 cylinders arranged in a configuration that had been calculated through hundreds of hours of engineering analysis to produce the smoothest possible power curve. But the truly revolutionary aspect was the control system. Vorster had designed a mechanical governor so sophisticated that it would automatically adjust the cutoff point of the steam admission based on track gradient and speed. As the locomotive climbed steeper grades, the system would subtly increase the cutoff, giving the locomotive more starting power. As it descended or as it reached the desired speed, the system would adjust to optimize fuel consumption. It was a system that required extraordinary precision in manufacture, tolerances tighter than anything previously demanded in locomotive construction. The gears and linkages had to mesh with almost Swiss watch levels of accuracy. The construction proceeded slowly, methodically, with constant refinement and adjustment. Vorster was obsessive, revising designs, demanding changes, pushing his workers to achieve standards that often seemed impossible. A bearing that was acceptable by conventional standards would be rejected as inadequate. A weld that would have passed inspection elsewhere would be cut out and redone until it met Vorster's exacting specifications. Money was no object. Resources flowed as needed. The railway wanted perfection, and Vorster was determined to deliver it. By 1940, the locomotive was nearing completion, though nobody outside the secure facility knew of its existence. The war had begun in earnest now, and Switzerland's position was becoming increasingly precarious. The country remained officially neutral, but the reality on the ground was far more complicated. Resources were becoming scarce. Copper was rationed, steel was difficult to obtain, and the Swiss government was increasingly concerned about maintaining the favor of its German neighbors while preserving its independence. It was at this crucial moment that a political decision was made that would alter the trajectory of the locomotive project. The Swiss government, understanding that the locomotive represented cutting-edge technology that might be valuable, made the decision to offer it to the German Reich. Not as a gift exactly, but as a demonstration of Switzerland's commitment to the German-Italian-Japanese alliance. The gesture was meant to reassure the Germans that Switzerland, while maintaining its official neutrality, was a reliable partner that could be trusted. Vorster learned of this decision with something approaching horror. His life's work, the culmination of 3 years of brilliant engineering, was to be handed over to a military power that Switzerland might soon find itself opposing. He protested vehemently, arguing that the locomotive represented Swiss technological achievement and should remain in Swiss hands. The railway's board was sympathetic but politically helpless. The decision had come from the highest levels of government. The locomotive would be delivered to Germany. What followed was an extraordinary chapter in technical espionage and political intrigue. Before the locomotive could be transported across the border, technical delegations from both Switzerland and Germany examined it exhaustively. German engineers were astonished at what they found. They had been expecting a large freight locomotive with some novel features. Instead, they were looking at something that represented a genuinely new category of railway equipment. The sophistication of the control system alone was something they had never attempted. The Germans faced their own dilemma. The locomotive was magnificent, but it was also complex in ways that threatened to make it difficult to maintain in the field. German locomotive maintenance practices were standardized across the entire rail network. A machine this sophisticated would require specially trained personnel, specially fabricated spare parts, specially designed workshops. Integrating it into the German railway system would be problematic, but the prestige of possessing such a machine, of operating technology this advanced, was too tempting to resist. The locomotive, designated simply as the Winterthur Special by those who knew of its existence, was delivered to Germany in the spring of 1941. It entered service on one of the most demanding routes in the German Alpine network, a mountainous section of track that was critical to military supply lines. And for approximately 6 months it performed magnificently. The German crews, carefully trained by Swiss technicians who accompanied the delivery, marveled at its capabilities. It could handle loads that would have required multiple conventional locomotives. Its fuel consumption was extraordinary. Its reliability was impeccable. But war has a way of disrupting even the most carefully laid plans. The demands on German manufacturing increased exponentially as the military situation became more desperate. The workshops that were supposed to maintain the Winterthur Special found themselves overwhelmed with routine locomotive maintenance. Spare parts that had been carefully fabricated before the delivery became impossible to obtain. The specially trained crews were reassigned to other duties. Within a year, the locomotive was beginning to show signs of neglect. Components began to fail. The sophisticated control system, with its precisely calibrated mechanical linkages, became subject to corrosion and wear that nobody could adequately address. By 1943, the Winterthur Special had become something of an embarrassment. It was too complex to maintain properly in wartime conditions. It required resources that the German railway system could no longer spare. It was relegated to less demanding service, eventually to storage. In the chaos of 1944 and 1945, as the war neared its end, the locomotive's fate became uncertain. Records of its location grew vague. Information about what happened to it became fragmented and contradictory. For decades after the war, the Winterthur Special essentially disappeared from history. There were rumors. Some tell it had been captured by the Russians and spirited away to Soviet railway workshops. Others claimed it had been destroyed in an air raid. Still others insisted that it had been carefully hidden by German engineers who wanted to preserve this marvel of engineering for the post-war era. The truth remained elusive, locked away in archives that were closed or destroyed, in the memories of men who were unwilling or unable to speak about it. It wasn't until the 1960s that researchers piecing together fragments of railway history began to suspect that the Winterthur Special hadn't been destroyed at all. Evidence began to emerge suggesting that it had survived the war, that it had been captured or recovered by forces who recognized its historical significance. Careful detective work traced it to a railway museum in Eastern Europe, where it sat for years in the open air, deteriorating, slowly being consumed by rust and time. In 1989, with the Cold War beginning to thaw and historical records becoming accessible, the true location of the locomotive was finally confirmed. It existed, barely, in a railway museum in Poland. The machine that had been built in secret during the 1930s, that had been delivered to Nazi Germany, that had become a symbol of what war does to even the most carefully preserved achievements of engineering, was still there. Covered in rust, missing components, its sophisticated control systems corroded beyond recognition, but still recognizable as something extraordinary. The question that faced the international railway community was agonizing. Should the Winterthur Special be restored? The technical knowledge to do so was fragmentary. Vorster himself had died in the 1950s, taking much of the design rationale with him. The specialized techniques and materials that had been used in its original construction were partly lost to history. A restoration would cost millions, would require bringing together experts from multiple countries, would be a project of extraordinary difficulty and expense. Yet there was something compelling about the possibility. The Winterthur Special represented an important moment in the history of technology and politics. It was a machine that had been built by one nation, stolen by another, lost in the chaos of war, and rediscovered decades later like an artifact from a sunken civilization. Restoring it would mean recovering a piece of history that had almost been lost forever. The decision to restore the locomotive came in 1995, driven by a coalition of railway museums and historical societies across Europe. The work began in Poland but was eventually completed in Switzerland, where the locomotive had originated. It took 8 years and consumed resources that approached what it had originally cost to build. Teams of metallurgists, machinists, engineers, and historians worked to understand Vorster's designs, to fabricate missing components, to restore the sophisticated control system that had been the locomotive's most distinctive feature. When the Winterthur Special returned to functional condition in 2003, it was hauled out of the workshop to a ceremony attended by railway historians from across Europe. Many of the people present had spent years researching the locomotive's history, trying to piece together the truth from fragmentary evidence and fading memories. Seeing it whole and functional again felt like witnessing a miracle, or at least something very close to one. The locomotive has never actually run under its own power since its restoration. The tracks on which it operated are largely gone, replaced by modern railway infrastructure incompatible with a steam locomotive of this vintage. But it runs on heritage railways, primarily in Switzerland, where it is displayed as a working museum piece. Railway enthusiasts from around the world make pilgrimages to see it, to stand beside a machine that represents so many themes that define the 20th century: engineering ambition, political intrigue, war, loss, recovery, the resilience of human achievement in the face of time and catastrophe. The Winterthur Special story is ultimately about the fragility of history itself. A machine that represented the cutting edge of technology in its era nearly vanished entirely. It survived not because of any deliberate preservation effort, but almost by accident, because it ended up in a location where it was too much trouble to destroy than to leave abandoned. Its restoration was possible only because enough fragments of information survived, enough people remembered enough details, enough archives preserved enough documents that its history could be painstakingly reconstructed. Dr. Vorster never knew that his creation would survive 2 wars and decades of abandonment. He never knew that it would eventually be restored with such care and attention. He died believing that his life's work had been lost to history, consumed by the machinery of war that he had watched with growing horror during the 1940s. But in a way that would have seemed impossible to him, his vision endured. The locomotive that he designed with such meticulous precision, that he built with such demanding standards, proved to be more resilient than he could have imagined. Today, when you stand beside the Winterthur Special, you're standing beside more than a locomotive. You're standing beside a conversation across time, a dialogue between the ambitions of one generation and the capabilities of another. The machine that was built in secret emerged into a world that it was never designed for, survived horrors that should have destroyed it, and eventually found itself restored by people who had never even heard of Dr. Heinrich Vorster. History moves in ways that no one can predict or control. The Winterthur Special is a testament to that truth and to the remarkable way that human ingenuity can transcend even the darkest chapters of human experience. The locomotive that almost changed history ended up proving something even more important. It proved that history itself and the achievements that define it are far more durable and valuable than the political circumstances that sometimes try to claim them. The Winterthur Special belonged to Switzerland first, then to Germany, then to Poland, but in the end it belongs to history. And history, it seems, knows how to hold on to its treasures, no matter how hard it has to work to do so.